native rate problem is about sailing. At noon, ship A is 100 kilometers west of ship B. So 100 kilometers west, we have to recall the direction. So do you still remember the direction of east, west, north, and south? So we have these directions. So we have North Pole, South Pole, and then the right side is east, the left side is west. Okay, the first sentence, ship A is 100 kilometers west of ship B. So this is ship A, and then this is ship B. The distance between them, keep the line straight, is 100 kilometers. So this is A, and then this is B. Right, 100 kilometers west of ship B, and then ship A is sailing south. South means going down at 35 kilometers per hour. So this is going south. What's the rate of change? The rate of change is 35 kilometers per hour. And ship B is sailing north at 25 kilometers per hour. North means going up. So this is going north, and then the rate of change is 25 kilometers per hour. So 25 kilometers per hour. All right. And then how fast is the distance between the ships changing at 4 p.m.? So they start at noon. Noon, what is noon? Noon means at 12. And then from 12 to 4, the hour is 4 hours, right? So how fast is the distance? What is the distance between them? The distance is, we use a different color to express that. So here is the distance between them. All right, so we have, looks like we have two triangles. Okay, let's write the givens. From noon to 4 p.m. So the total is 4 hours, right? And then what else do we need to know? How about this? We need some x and y. Okay, so this is the starting point. This is the starting point. We have A and B, and then A is going down, B is going up. How about this? We call this x, and then we call this y. So that means x is the distance that ship A travel, right? So x is the distance that ship A travel. And then y is the distance that B travel. All right, we got x, y, and z. And what is changing? The distance between them. Okay, we need one more variable then. Then we need a z. Then z is the distance between A and B. So z is the distance between A and B. It is changing, right, with respect to time. Okay, what else? What else can we do? The next step is we have to set up an equation. All right, in order to set up an equation, I need to do one more thing. So let's use a different color to do it, because I want to apply Pythagorean theorem. I want to set up one equation. It looks like I don't see any one equations right there, right? So you have two triangles. You are thinking, all right, maybe we have to set up two Pythagorean theorems and then plug in one to another. We don't need to. So let me use blue. This is what I am going to do. This is y, right? So I am going to do a dashed line. So I call this my y as well. And then what about this one? This one and 100 kilometers are parallel. So this is 100 kilometers. Okay, then what is the Pythagorean theorem? The Pythagorean theorem is I am going to use z, I am going to use x and y, I am going to use my 100. Pythagorean theorem. How do we do that? The square of the sum of the square of each side is equals to the square of the hypotenuse. So let's go ahead, write it out. So we have one side, the length is x plus y square plus 100 kilometers square equals to z square. Okay, and then we are going to take derivative, that means I expect to see the rate of change of x, y, and z, right? So do we know dx, dy? In case you don't want to touch that's okay. Let's go ahead and take the derivative. So the derivative of x plus y squared, what rule do you have to use? First, we have to use chain rule, and then we use implicit differentiation. So using chain rule, we bring the 2 down, and then we have x plus y, and then we multiply the derivative of x plus y with respect to t. The derivative of x is 1 times dx dt using implicit. The derivative of y is dy dt. So now x plus y squared, the derivative is done. And then the 100 squared is a constant, so the derivative is equals to 0 plus 0. And then we have a 2z, and then a dz dt. dz dt is the rate of change of the distance between ship A and ship B. Okay, do we know dx dt? The answer is yes. Do we know dy dt? The answer is yes. The answer is written on the picture. So dx dt, what is dx dt? Look at the picture. How fast is ship A moving? Ship A is 35 kilometers per hour. I want you to write the unit. And then dy dt is 25 kilometers per hour, right? So we know x, dx dt, we know dy dt. What else do we know? Can we calculate what x? X is a distance, right? So the ship is looking at x. The ship A is moving 35 kilometers per hour. How many hours they spend on sailing? From noon to 4 is 4 hours, right? So your speed is 35 kilometers per hour, and you spend 4 hours on it. So the total is 140 kilometers per hour. What is this equals to? This is equals to x. X is a distance. dx dt is the rate of change, right? Which is the speed. And then y is equals to the other ship. They spend 4 hours, and what's the speed? The speed is 25 kilometers per hour. So it's 100 kilometers per hour. All right. So now we found dx dt, dy dt, x and y. We can do some plug-in. So we have 2 times 140 plus 100 and then 35 plus 25. The 0, we can ignore that. And then we have 2z and then dz dt. We still have 2 unknowns. I can't solve for anything yet. But before we move to the second plug-in, which one are we looking for? Are we looking for dz dt, or we are looking for z? To answer this question, you have to read the problem. My question is asking this: which one are we looking for? Z or the rate of change? Let's go back to read the problem. So the problem is how fast. What is how fast? How fast is not a distance, right? What's the distance between them is the distance. I am asking for how fast. How fast is the distance between them at a specific period of time? So this is what we are looking for. I don't know dz dt. So that means that z, there has to be a way to figure out what z is. All right, can we figure out what z is? How? So go back to the picture. I am going to use another color. So I'm going to use red this time. Or actually, I don't need to. I will just use a highlighter. So what we are looking for is I will have to use this triangle. So this, and this. Since I know x, y, I know 100, it is not that hard to find z. So this is what we have right here. Let's do it in red. So we have this, the big triangle, right? And then we have x and y. So right here, what is my x? Y is 100, x is 140. So this is 100, this is a z. Using Pythagorean, I can find z very easily. So z squared is equals to 100 squared plus 100 plus 140, that is 240 squared. And then z is equals to 260 kilometers. So this is going to be 260 right there. So now I can easily solve for the rate of change. Let's do it. So we have 2 times 240, and then 35 plus 25 is 60. So that equals to 2 times 260 divided by dz dt. So the dz dt is equals to the right side, the left side divided by the right side, times 60 divided by 2 times 60, and then just approximate this using your calculator. So the dz dt is equals to 55.4 kilometers per hour. Usually 1 to 2 decimal places are enough. Alright, that is the final answer to this problem. I see you all in the next one.